All right, today we're going to look at equations of perpendicular lines, with our goal being how do I write equations of perpendicular lines? So first, let's just review what are perpendicular lines. So we're looking at two lines that intersect, but specifically they cross at a 90-degree angle or meet at a 90-degree angle. So perpendicular lines. If we were to take a look at the line on the graph here, okay, we've got a positive slope. We could even calculate that slope using our rise over run trick. Looks like a rise of 3 and a run of 2. The slope's 3/2. Let's say I wanted to graph a line that was perpendicular to this one. So let me grab my line tool here and see if we can draw a line that looks perpendicular to it. So I'll start up here and go, maybe right in there? Maybe more like that. That looks pretty good. Looks like we have a right angle there. 4 right angles technically. So I wonder, what is the slope of that line? Well, to find the slope, I need to find some points, some ordered pairs along that line. And it looks like we've got some pretty good ones right there. And we see a consistent pattern. So it looks like I am going down 2 and to the right 3. So my slope of that line is a negative 2/3. So what I want you to do is really look at those two slopes and compare them. It looks like they both contain the same numbers, the same values. However, the fraction was flipped upside down. Okay, the 3/2 from the first line was reversed. We call that a reciprocal in math. And it also looks like the red line had a positive slope because it went up. So if I'm going to draw a line that is going to meet it at a 90-degree angle, I have to make sure that it's going down. In other words, having a negative slope. So one's positive, one's negative, and I have reciprocals. So to put this all together for your notes, that concept is called opposite reciprocals. Perpendicular lines have slopes that are opposite reciprocals. So the word opposite just implies different signs. So I have one that's positive, one that's negative. And reciprocal, as I mentioned, is when you basically flip a fraction. You switch the numerator and the denominator, or the rise and the run in this case. So if I have an equation, y equals 2/7 x minus 5, I see that my slope is 2/7. It's highlighted there. I want to think about what would be the slope of a line perpendicular to this. So what is a slope that's an opposite reciprocal to 2/7? So what I would have to do is identify that this is a positive fraction right now. So the opposite of that is going to be a negative value, negative fraction. Okay. For reciprocal, I have to flip the numbers around. So instead of 2/7, I need 7/2. If I put those two concepts together, I get an equation like this that has a slope of negative 7/2. And if I have that relationship between the slopes, I can say that my two lines will be perpendicular. The y-intercept has nothing to do with it this time. We did have to make sure they were different with parallel lines, but not with perpendicular lines. So here's a little matching activity. Let's see if we can match equations together whose lines would be perpendicular. Let's start with this first equation, y equals negative 3/4 x plus 1. And what we're really looking for in the equation is we're identifying the slope of the line. And I can see that in my y equals mx plus b form, the slope of this line is negative 3/4. So what would the slope of a line perpendicular to this have to be? Well, we'd have to have an opposite reciprocal. Well, the opposite of a negative number would be a positive number, and the reciprocal of 3/4 is 4/3. So I'm looking for an equation that has a slope of positive 4/3. And I see I have one over here on the right-hand side. Let me just move that over and match them up. Okay, so those two would be perpendicular if we were to graph them, because their slopes are opposite reciprocals. Let's see if there's any others. Let's go with that long one in point slope form. Okay, here I can see that my slope is -2, which, keep in mind, anytime a slope is just a regular number, like an integer, we can turn it into a fraction by putting a 1 underneath it. So what would the opposite reciprocal of this be? Well, I'd have to change it to a positive, and I'd also have to flip the numbers around so that it's 1/2. So I'm looking for an equation that has a slope of 1/2, and I see I have that down here on the bottom. Positive 1/2, negative 2/1. Those slopes are opposite reciprocals, so I have two more equations of lines that are perpendicular. See if there's any others. Down at the bottom, I have this equation, y equals x plus 2. And I keep in mind that the slope here is 1 because it's 1x. And as a fraction, that means it's 1/1. So what would the opposite reciprocal of 1/1 look like? Well, this one is positive, so I'd need to find a slope that's negative. And if I flip the fraction upside down, it's still going to be 1/1. Okay, so in other words, I need a slope of -1. I look at my equations, and I see that I have one right up here with a slope of -1. So those two, if you were to graph them both on the same coordinate plane, would be perpendicular. All right, anything else? I've got 3 equations left. I think it's safe to say I can eliminate y equals 2x minus 9 because there's no way I can flip a fraction and get a 3 in it. But I wonder if these last 2 equations are actually perpendicular. I want to start with the one that's already a fraction. We have -1/3. If I flip the numbers around, I'd get 3/1. And if I change the sign, it would have to be positive. So positive 3/1 would be my opposite reciprocal slope. And that's exactly what I have in that other equation. So these 2 equations would represent perpendicular lines as well. So how are we going to use this? Our goal today is to write the equation of a line that is perpendicular to this equation that's given, and it goes through the given point. So we want to think of this as 2 separate lines. Now let's actually start by looking at the graph. Line number 1, I know, has a slope of 1/3 and a y-intercept at -8. So if I were to graph this equation, I would need to start at -8 on the y-axis, and I can plot additional points using my slope. I have a rise of 1 and a run of 3. I make sure that my line is going up and to the right anytime my slope is positive. All right, so there's line number 1. Now line number 2 says write the equation of a line that's perpendicular to that one, and it goes through -3, 5. So I know that -3, 5 is a point on my line. So the x value is -3, the y value is 5. But I have to not make it parallel, but perpendicular. So I have to think about what is the slope on the other equation. Well, I'm going to need to use a slope that's the opposite reciprocal of 1/3. -3/1 is the same as -3. So I can plot more points by going down 3 and over 1. Or I could go up 3 and back to the left 1. Now let's see if I can draw a straight line. All right, not bad. It wiggled a little bit. But it definitely went through the ordered pair, -3, 5. And you know what? That looks pretty good to me. I would believe that those 2 lines are perpendicular because it looks like they meet at a right angle. So let's go back to the algebra. This is just to give you a visual idea of what we're trying to do. We're starting with this equation, y equals 1/3 x minus 8. So this would be a good thing to put in your notes. We see that the slope is 1/3. The y-intercept is -8. Now, when we're solving this algebraically, we don't really care that the y-intercept is -8. We don't really do anything with it. But what we do care about is that slope. We're working with perpendicular lines, so the slopes are opposite reciprocals. The opposite reciprocal of 1/3 is -3/1, or we can just say -3. We also know that this line has to go through the ordered pair given here, -3, 5. And since we're given a point and the slope of the line, we might as well write the equation in point-slope form. So that's the long one that has the parentheses in it. We've been writing a lot of equations in this form lately. So y minus blank equals blank times x minus blank. Our slope goes after the equal sign. Our x-coordinate goes in the parentheses. And our y-coordinate goes out front by the y. So y minus 5 equals -3 times x plus 3. Remember that when I had x minus -3, I make it a plus sign instead. Then I'm going to go ahead and distribute the right-hand side because my goal is to get my equation to look like the first one. I want y equals the slope times x and then the y-intercept, slope-intercept form. So I distribute first, -3 times x and -3 times 3. And then I want to get y by itself. So I undo the subtraction by adding 5 to both sides. -9 plus 5 is -4. I would get the equation y equals -3x minus 4. So I'm going to go back to the graph here in just a moment. If you need more time to copy this down, please press pause. All right, so going back to our graph, we did all this work earlier, but we never actually looked at what is the equation of that green line. We talked a little bit about how the slope had to be -3/1, but we didn't actually identify where it crossed the y-axis. But when I use that slope to go down 3/1, I see that I actually crossed the y-axis right there, which is 4 units below the origin at -4. And if we look at our equation that we got on the previous page from the example, it has a slope of -3 and a y-intercept of -4. Here's one more example. If you feel comfortable doing this, I would encourage you to press pause and see if you can write the equation on your own. If not, continue watching, take notes, and let me know if you have any questions. So write the equation of a line that is perpendicular to y equals -2x minus 8. And it also goes through the point 4, 0. So we know that this line that we're starting with, called line 1, y equals -2x minus 8, we know that the -2 is the slope of the line, and the y-intercept, again, is -8. We don't really care about the y-intercept, but we do care about what the slope looks like as a fraction. Because in our other line that we're trying to write, it has to be perpendicular to line 1, so the slopes must be opposite reciprocals. Since line 1's slope was already a negative number, line 2's slope is going to be a positive number. And we just have to flip the fraction upside down. So instead of a -2/1, we would get a positive 1/2. So the slope of our other line has to be 1/2, and it has to go through the point 4, 0. Since we know a point on the line and the slope of the line, we're going to go ahead and write our equation in point-slope form, plugging in our slope for m, our x-intercept, and our y-intercept in the correct place. I want to get this equation into slope-intercept form, so I distribute on the right-hand side by multiplying 1/2 times x minus 4. I get 1/2 x minus half of 4, which is 2. And normally I'd say, well, undo the minus 0, but adding 0 isn't going to change anything because anything plus 0 is itself. So I can just treat this as y, take away 0 is just y. And the 1/2 x minus 2 stays the same. So if I were to graph these two equations that I put a box around, I would get lines that are perpendicular because they meet at a 90-degree angle, and the ordered pair 4, 0 would be on that second line.